So we're going to talk about composition of functions in this video. Basically, imagine if you have a function f of x as 2x plus 5, and you have another function g of x as 3x squared. The composition of functions, you would notice that they write it like this, or the other way they write it is like this. The idea is, what if I substitute the value of g of x into x in f of x? So that will become 2 into 3x squared plus 5. So basically, wherever I see x in f of x, I substitute g of x. So then this becomes 6x squared plus 5. And if somebody says, well, what about the reverse? What if somebody says, what is g of f of x? Then you take f of x and you substitute it into g of x. So basically, what is f of x? 2x plus 5. What is g of x? 3x squared. So 3, and instead of writing x squared, you write 2x plus 5. So you put in f of x everywhere you see x in g of x. So let's take a quick step back. The composition of functions involves a situation where you're given two functions, for example. You could be given more, but you take the g of x value and plug it in for x in f of x. That's how you find the composition of f of g of x. Or if they say, what is g of f of x? You take f of x and you substitute it in to x in g of x. Now, this problem right here has an order of operations element. You can't do this, you can't just distribute the 3 in. So we have to do this part first. So 2x plus 5 and 2x plus 5. We have to do that. And then we have a 3 waiting outside. This part here we use FOIL, or binomial multiplication, polynomial multiplication. So polynomial multiplication. Now you might remember that this is discussed in chapter 5 of Tyler Wallace's algebra book. But basically we do this part first, and I know some of you like to do it like this, which is a great idea too. Some people do it like this. And the idea with that is like a Punnett square of biology. You basically multiply the 2, right? And then you have 10x, then you have 10x, and then you have 25. So we know it's going to be 4x squared plus 20x. Well, actually, let's write it out step by step. And then all of this has a 3 on the outside. But then we can add like terms, right? Which is discussed in 0.1 to 0.4 of Tyler Wallace. Again, I give you these notes so that if you ever are confused on any topic along the way, you can look it up. And let me just say two ways to look up a topic, a healthy way to do this. The first way is, if you type in Google, like terms PDF examples, that will pull up examples of that concept in PDF documents, which is a great way to sometimes see the pattern, because math is about patterns. But the second way to find this is to either use a website where there's a teacher like Khan Academy, or a different website for math. This is specifically for math. I don't necessarily recommend all websites for everything, but for math, Khan Academy could work. You say like terms and then say video. So then, or here it would be polynomial multiplication video. So I'm trying to give you guys tools that will then help you further your learning. I know that technology is a tricky topic for some people. I think it has its place and we should use it when we can, but definitely we just have to watch out and be careful not to allow it distract us. Even I have to watch that in terms of, I'm supposed to do this assignment of learning this thing, and the next thing I'm reading about the history of Japan in 1975. It's like, why did I get distracted? That's just in human nature. So just let's be careful as we use technology. So here we can add like terms. And why can we add them? Because they have the same variable in the same power. So that becomes 4x squared plus 20x plus 25. And we have that 3 outside. So that becomes 12x squared plus 60x plus 75. We just found the g of f of x by substituting the value of f of x in g of x. Okay, so that's how we do that. Let's see a few more things here for composition of functions. let's see, they can also give you situations whereby something like this happens, where somebody says, what is g of f of x? And then they instead of putting x here, they might put, let's say, 2. What that means is that you put in 2 everywhere you see x, back in our problem here. So basically, we already did g of f of x, right? That was the first step, is do g of f of x. And that was 6x squared plus 5. Now, if we put a 2, specifically, it'll be 6 into 2 squared plus 5. That becomes 6 times 4 plus 5, which is 29. That's how we do that problem to the end. Okay, we're going to stop and we'll come back to the next topic.